Okay, yeah, let's go with everybody who might wake up at 9:30 on a Saturday after a conference would be here. I hope everybody liked the conference. Oh, yes. Okay, everybody is still asleep. Good, good. So maybe people wake up. Okay, my name is Dietmar Kühl. I work at Bloomberg. Actually, I have maybe a better slide for that. I work at Bloomberg. I work at Bloomberg for 18 years. I like it over there. The thing I'm going to show over here is not something we use yet at Bloomberg. I hope we get to using something like that eventually. We don't do it now, although it is actually relevant in my area. I work on market data distribution, basically getting huge amounts of market data, what we call ticks, from an upstream source and sending that down after meddling with it to all our clients. So if you have seen a Bloomberg terminal or use our enterprise products with real-time updates, moving market data goes through my software, the infrastructure my team is working on. All right, what I want to do today is I want to create a very basic but working asynchronous HTTP server using really complicated technology I hear, sender receiver, together with coroutines. And I hope you see that actually it is not that complicated at all. Yeah, so the objective, very basic HTTP. So I will not implement the entire spec because that part is largely not that interesting to going all the details, parsing things really properly. It can be done, but we all know how to implement normal sequential code. Once you have a header, decoding all that stuff inside, not that interesting, I hope. We can talk about that as well, but it's not that interesting. The asynchronous stuff is way more interesting in my mind. I want to obviously support multiple clients being live at the same time. At the same time, I only want to have one thread, potentially. I'm happy to use many more threads if I have them and I need for resources, but I shouldn't, just because I want to have multiple connections or waiting on multiple sockets, I need to run multiple threads. That would be bad. And this is what everybody does in that space anyway. Basically, everything is asynchronous. You wait in one thread for many outstanding I/O. I'm going to use sender receiver is currently a proposal. It's not in the standard yet, so there's no support in the standard library. So I'm going to use an implementation which tracks the standard. It's called standardization, maintained by NVIDIA, but with contributions from many other areas, many other teams, which implements the async proposal. I use a minimalistic sender-receiver networking interface, which is a proposal I'm trying to progress together with possibly others. So both of these implementations are available online on GitHub, so you can get them, and if you want to play with that. The things over here is no magic. I don't have any special code. It's all on GitHub. All right. So let's get to it because, hey, it does take some time to type these things in, but it shouldn't be complicated. So let's get to the chase. The basic design, relatively simple, as one would imagine. We have a main which kicks things off. Sorry. The main will contain primarily something which is called an async scope, which is collecting outstanding work and starting and releasing that eventually when it's done. And kick off the first item of work, which is basically just a server entity, essentially a socket where incoming connections are listening on. And that spawns new work in the form of client connections. And then each client connection processes requests until it receives an error or doesn't have keep alive or any of these things. So very, very straightforward. I hope all that makes sense. Not particularly interesting yet. So let's go and do it. All right. Wait, there's an entire server sitting in here. That is not right. Okay, I know what this is. What that is. Okay. So, sorry, I didn't. All right. I wanted to start with pretty much just the hello world. There's some, you see it's line 66 or something. There's something, my memory is bad, so I have some reminders for little things and a whole bunch of, okay, let's get rid of that as well. And a whole bunch of headers. So we don't bother time including things. But there's actually nothing which is not sitting in some header. And so, hello world. Compiles, runs. I'm not going to test that. I will start off with a little tool which I find very useful to see that things actually finish and get released. I don't know whether many people use that, and it may be entirely boring, but let's say we create an alias for onExit, which is actually just a unique pointer of char const, that const is important, together with a little bit of an interesting deleter, right? You know that in unique pointer, you can have a deleter, and the deleter I want over here is basically just a function which takes some message, and we just write the message, maybe a new line. So I'm going to use that to show that things actually finish and terminate, just to get that out of the way. On exit message over here is, well, goodbye. I'm not doing the goodbye yet. I'm just showing that this is what it does. And let's quickly run that to settle expectations. And what? Oh. Sorry, let's run it again in a clean state where there's no other gibberish. So it basically says, as one would imagine, we set up goodbye and hello world, it says hello world and goodbye. All right. So that is not really HTTP server, but creating an HTTP server, what we probably want to do is, let's say we just make a server. That is, and we create a function for that. The function will return something slightly odd. Exec, the std exec implementation tracks the standard, the proposal for P2300 and what is currently in the standard, and that moves into a namespace called scd exec. There is something being proposed, but it's not yet it's not yet down in the process, which is called a task. We will get that. If you want to know how a task look like and how to implement something like that, see my previous year presentation. I implement basically a fundamental task over there. That one is more fancy, but conceptually just the same thing. It's basically a coroutine thingy. And what we do in here is kind of, all right, we make a server. And I will just start off with saying, all right, let's say inside server, to see that something is happening, and similar to the thing on message, I am exiting the server. And then to make something a coroutine, I need to have one of the coroutine keywords in here. For now, I will just co-wait something which is already in the standard, and this is suspend never. And actually, this is a very non-interesting coroutine so far. All it does is it prints something when it started, and it prints something when it terminates. Now, if I create that, I can run it, and what will we see if it runs? We see, oh, wait. I call make server, this should, say? Oh, suspend always. Yeah, but it should also write inside the thing. It also doesn't write that, right? I can go with, yes, I should say suspend never. You're right? Oh, man. Okay, eventually we get there. Suspend never, right? But it doesn't print anything, right? That's awkward, right? As you know from, well, some people shake their head. No, it's not awkward at all, because this make server actually is basically a factory function for a coroutine, and that is set up to suspend initially on startup. As a suspended coroutine, it returns a handle to that, and we need to do something with that. All right, that may put people off, fine, but we need to do something, and this is where this funky async scope I was mentioning comes in. So let's get an AC. Also from sud.exec, it's also proposed. It's also in the early stages. Let's create a scope. And what we do with the scope, we basically tell the coroutine we get that it should run over there. So the function to do that is called spawn. Don't confuse spawn with spawning threads. It does no such thing. It takes the sender, or a coroutine, a task behaves like a sender, and connects that with what is called a receiver, producing an operation state and starting that. Nothing of that necessarily creates a thread. The sender we pass in may create a thread, probably it doesn't, but in this case it certainly doesn't, right? We see what it does. So this guy should now, hopefully, if everything goes well, be much better and actually say, yes, indeed, we are hello world, and then we are inside the server, we exit the server, and everything is great. And we can obviously, if we go the other way around, we can get only half of that by basically suspend always, in which case we basically have created a coroutine which, it doesn't finish. And it aborts over here. Now, the abortion, the assert at the bottom is actually kind of expected. The reason it creates is the async scope takes on work, starts that work, and it expects to be destroyed when all the work is done. But the work is not done yet, because actually the coroutine is suspended and something needs to finish that. We could try, not sure whether that actually does work, but we could try, and it may work actually, to just terminate that thing. We go async scope, get stop source. So the way cancellation works in the sender receiver world is you have stop sources, you get stop token out of that, and every work either registers a callback with the stop token, or observes the stop token and is actively running. And if that is stopped, it should finish. Let's see, that may actually work. This, yeah. Say? Oh, functions call of get stop source, yes. So something like press stop, and I hope that now we actually don't abort, but we do abort, okay? I'm not entirely sure why that is. But okay, let's go. That's not necessarily what we are yet interested in. Eventually, we want to stop work like that. What we really want to do in here is, as I said, we want to create a socket and basically wait on doing that. So the current way I'm doing things is somewhat along the lines of what the networking TS did. So to create a socket, I basically need a few things. I need a TCP acceptor, which is basically, acceptor. This guy gets a few constructor arguments. It gets as constructor argument context, which I don't have yet, and an endpoint. Not endpointer, endpoint. So the endpoint is basically just the address of where we want to connect things. So let's go with, I think there's an endpoint in here. What's it in TCP? Endpoint, TCP endpoint, and this is, let's call it endpoint, whatever. And we need to just set that up. I'm using prefix stdnet in a similar way as stdexec to say, right, I'm proposing these things, they're not yet there. And I'm gonna use address v4 and any and just an address, which I can use. Obviously, a normal HTTP server would listen on port 80, but I don't want to mess with any kind of privileged port thingy. And then I need this context thing. The context thing, well, for the coroutine, we don't really care too much what it is. On the outside world, one thing we know is if we spawn work on the context, we basically want to have all the work done before the context gets destroyed. This is what the async scope deals with. So basically creating the context before the async scope should nicely deal with that. I'm going to use an IO context, which is just set up to basically do a run loop. At the moment, this implementation will use lib event, but it can use whatever poll, epoll directly, or libuv. Should all be easily implementable, including potentially, this is one of the design questions, design decisions we may have, whether we expose the interface, how you could create your own context for run loop. Okay, so this should basically create us an, now I need to press this button over here. This should create and compile to create us a socket, which doesn't do anything. So that immediately terminates. What we normally do is we spin until we are done, sort of, right? So let's do while true. And in here, instead of suspend always, we basically just go and say stdnet, let's call it async accept for now, or this is what it's called currently in the library, on the acceptor. And this looks a little bit like the asynchronous version if you use the normal BSD socket API. All right, we basically accept on a file descriptor. Okay, here's a little bit more fancy thing which cleans up the file descriptor and is called an acceptor and has maybe a little bit of more interface. And just we stick a co-await in front of it. And what we do get out over here is basically the completion signal of the accept function, which has a set value with a stream and an address. So basically, so you can get an idea of where did the client come from. So let's get those. So we have a stream and let's say a client. We nicely destructure that so we don't have to do anything fancy. And now we can start seeing, all right, we get a connection from client. Okay, so yeah, let's run that. And what? Say? Square brackets. That should be fine. I think it compiled. It may have just still been running or something. Okay, this is the interesting challenge always of running things online, live. That is set up. Well, oh yes, yes. Lucian is right. I need to join the scope. And if I try to do that, then yeah. Say? Well, okay. Yeah, it's fine. There's some joiny thing. Now I may not know what the problem towards the end might be, but okay. I had actually expected, oh, right. But one thing we actually want to do is once we have spawned all our work, really this thing is just kicking things off. Even after kicking off, the server currently would just go into accept. the coroutine suspends, it falls out over here, and we terminate. This is why that happens. The join, we cannot actually yet join anything anyway. We first need to basically run the I/O. And the idea of context.run is, as long as there's outstanding work inside the I/O context, that thing keeps running, and it terminates when there's no more work. We could run one. If we want to get more control of what is executed, run one would basically find one work item, execute that, tell you whether it executed anything or not. And you could put a loop around that, but run is just that loop. Okay, so if you run that thingy, then running, then it should sit inside, and we need to go somewhere else to basically see a connection, and we can see connections from clients coming, which is kind of cool. So if that were a browser, we would now have a client connection. Hooray! Okay, so all we need to do now is kind of the boring stuff of going, all right, we do just the same, we spawn a little bit more work. So we do pretty much the same thing as before. We do get the client, we move the stream in. So streams are basically move-only entities. You cannot copy them. It doesn't make sense to have two copies of the same stream. So we need to move them. And yeah, once we have created the coroutine make client, we need to do something with it. We don't want to co-await it, because if we co-awaited it over here, we would block until the client is done, and we couldn't connect any other connections. We don't want that. So you probably want to do rather something along the lines of scope, spawn the make client, which we will create in a moment. We don't currently have that, so we just pass that through. That is easy enough. And then just create another task to do the client. And we basically just have a, well, whatever, auto stream. And this guy is almost certainly in some shape or form eventually co-awaiting the SCDNet, and this time it does instead of that, well, okay, to set that up, I need a little bit more async receive of a stream. It takes a buffer. There's basically an abstraction over a sequence of I/O vecs. And where do we get the buffer from? Well, let's say we just use a buffer, something like that, V of 60. And just to do a little bit of the same things, I do like to see things are coming on and going away. So let's say we exit the client over here and we are inside the client. And then running that thing gives me an error somewhere. No matching function call for make client. Oh, yes. Yes. Thanks. Right. So here's our running server. Let's go and reload something. Are we not going to exit yet? Okay. So this thing cannot be reached, but you actually see a whole bunch of connections have been come in and maybe retried. Fine. So we get something. All we need to do now is to create our little client to be a little bit more constructive of what do we do with the data. And effectively, we need to read until we have a full header. I like to use in these things relatively small buffers initially, so that I actually test the logic, possibly expanding buffers. Right? Because if you actually go, all right, let's try something with 65K or something, a normal HTTP header easily fits into that, but a real HTTP header may not. So you probably want to have a little bit of resizing logic for that. which makes it a little bit more annoying, but well, so we need to maintain. I think it is reasonable to start off as doing like the buffer thingy and trying to deal with cases where you have partial reads, partial writes of what you want actually want, and deal with the corresponding stuff. So what we really want to do over here is something along the lines of, right, we read, we probably want to have kind of how much we read, and then we want to check whether we read anything at all. So we terminate like if there's nothing more to read, then we probably want to finish and do that like that. And inside, all we do over here is, right, if we have actually read something, let's make our end a little bit bigger, not this way around, n plus n. And then the other side, obviously, is if we get a buffer, we don't want to start reading right at the beginning, so we need to do a little bit data plus how much we have read so far, and the size of the buffer needs to be then smaller. I hope that all matches up. So now we have read up to end characters, and we can see whether we have read enough by basically just going, all right, let's do a string view from our buffer.data and buffer.data plus end, and go, well, we know if HTTP header has finished, if we read so far. And we can just go and say std cout read header. So you can see that. Most likely, we eventually read the entire buffer. So we may need to increase the buffer. Let's do that. If the buffer.size is the end, then we need more buffer space. v.resize, and let's go. We want to resize by size times 2, maybe. All right, reasonably dynamic. Hopefully all working, of course not. Does it want the parentheses? Okay, so hopefully if we try that, we should see that we eventually have read a header, and then we are inside the client again. Now we see lots of header reads. The server apparently tries to read, and actually once we have read the header, we haven't cleaned things up. Right? So probably the next thing we want to do over here is, once we have processed, we have now a buffer which may have trailing stuff, and we should remove the prefix. Let's start off doing that. Just go b.resize. I'll say, yeah, no, we need to remove things at the start. So let's do b.erase, b.begin, and b.begin plus end. This is basically moving all the data from the back to the front. And then we need to, oh, okay. We actually, we don't want to remove everything up to the end. We actually want to have something different. We need to keep track of a position, because we may have overread beyond the header, right? It may have already sent some of the body that we probably want to keep. For now, we basically should have a position, and this guy, we just go auto pause equals. And this actually, there was a bug in the previous code as well. I didn't actually read the header. I need to do a different comparison. Pause equals, not equals, string view end pause. Sorry about that. that now should read the header, and then once we have processed the header, get rid of that and possibly do another header. Okay. Doing quite well. Say? I have to stop the old binary, yes. That is a fair comment. Okay. That looks saner, so we have read a header. And now the boring part of actually just, well, you could argue much of that is already boring because that looks already pretty much like asynchronous code, except for a little bit of a core wait thingy in here. Now let's just quickly decode some bits of the header, and I will be sloppy. This is not really how HTTP is request or is meant to be parsed, but like I said, that is a little bit boring material in my mind. So I just want to go and read things and go and say, all right, I want to get a method out of that. I want to get a URL out of that, and to complete reading the first line, at least a version, and we just go something like, all right, if in method and URL and version, then we actually have a lovely header. And let's go for now immediately and go and say, I want to, I've read a header, I've read these things, but I don't have a page yet. Let's let the server know. So let's send a response, and our response, we just go relatively simple. We do a 404 and say not found with an empty body. And we quickly implement a send response, which, as you would have guessed, is a coroutine. Now, one thing I do not quite like about this implementation is when you actually create a coroutine, it basically needs to somewhere put the coroutine frame, which it pretty much allocates on the heap. So each time I create a coroutine over here, it actually does an allocation. It also does a lot of allocation for the string management I do in the code, but the string management I can get away with, all right, I don't use strings. I'm a little bit more careful what I do, and I use string views instead of having a repeatedly increasing buffer. Maybe I have a maximum size buffer and I don't reallocate. So I can actually get rid of a lot of allocations, but getting rid of the allocations from the coroutine is a little bit more tricky. And I hope to get to the point to say we create actually a send response, which is not a coroutine, but a send natively. But that's a little bit more complicated, so I'm not going to do that right away. And I will also give that thing for now a sloppy interface in the sense of I'm doing allocations, but this is, all of these can be get rid of if you actually want to. So we create a head, we get a string doing the body, and creating an an HTTP response. I'm actually even, like all of these things can be done way more effective. But let's just go. So we basically, to print these things, we do, I think it starts off as the version. There's a blatant lie. I'm not really conforming to that, but reasonably close. And then we go and say, yeah, just for good measure, we do a content length, and this will be body.size, and this is the header of our response. So more of these fellas over here, and then we just print the body. Okay, now we have the thing. Like I said, lots of stuff being done in a sloppy way, but this is in my mind not really the interesting bit. And over here to basically send the stuff, we do something very similar to the receiving. We do an async send. Oh, I need to put that into the correct namespace. Async send with the stream and we need to put a buffer around that, buffer of data. And then I forgot earlier that the response need to know where to send the response. Say? Upstairs. Oh. Funky typos. Thanks. Okay. So I'm not sure whether you will see the difference, but I hope there's a difference. You can see it does now an 4.4, which is just what we sent. Yay! So we basically started to respond. And well, from now on we could just go, oh right, great. Instead of a 4.4, maybe we go and say, well, if the method is get, and we basically have something that's, again, this is not really not production code. Do not do what I do now, right? Do as I say, not do as I do. I will make that a global variable just because I'm too lazy to pass it through. So if my global variable data contains no, not like that. If this guy contains URL, then I will write a response. Else we do the for form. And then, well, the intention I have over here is to go, all right, I have an IF stream in, which is open with what comes back from here. And we just do send response with stream and 200 and okay or something. And then we read a string. So a string coming from there is an I stream buff iterator char of in. Okay. Reading my string, and now I just need to have a little bit of a mapping from, I don't want to just go, all right, take the URL and read that from my file system, otherwise I have hackers trying to read my disk, right? So let's not do that. But it's reasonably easy to contain that, and we say, all right, we just create a mapping from string to string, which is our thing I called the data up there. And this is just populated with a few files I'm happy to give away. This is basically hello.html. Oops. HTML. And data, let's say, oh, I need to do that a little bit different, but okay, PNG. This is obviously a mapping. And this is slash or, and this is after PNG, I think. Something like that. Sorry? Thanks. And something more. Oh, contains. ignoring return value. Oh, right, yes. This is a nice hint that I read. So we want to co-weight that thing actually. Okay, let's stop the previous one, run this one. And if everything goes well, we see, hello, ACCU. All right, we have a working web server. 40 minutes from 0 to basic working web server. Now, bells and whistles, we can add, we can finish, or we can carry on doing a few more interesting things. The first of which, like this is the minimum thing I wanted to achieve. Now, maybe make it a little bit nicer. For example, I said, creating a coroutine over here every time is slightly annoying. Maybe we would be better off if we don't create a coroutine each time and rather made that a sender. But the main use, I imagine, how people are going to use sender and receivers is they actually use the coroutine task to do their work. Then test that, and maybe during testing or maybe after testing in production realize there's a performance problem over here. Maybe we want to improve that and turn that into something which is not a coroutine and doesn't need allocations, and you basically optimize things there. But even that is unusual. It's not things we do every day, and I may screw up things right over here, but it's not super complicated. The idea is basically, all right, my send response will pretty much maintain the same interface and functionality, but instead of returning a task, let's actually create a coroutine. Create a sender directly, which does some of that. And how to go about that? Well, we basically pretty much as in the previous thing, we probably want to create just our final data. Okay, let's actually copy that as well. So we create the data and then we do something with that. And what we do with that is we basically return something like called let value, which nicely lets us capture data. So let value is a sender which when its upstream completes, so actually you need an upstream, and it's not an SCD net but exec. It basically takes the result of its upstream and takes a function which creates a new sender. So that's sounds a little bit complicated, but actually isn't really. What it allows us to do is that we go over here, we wanted to have somehow the data thingy, and we can go, data is our stream, we capture that, because we need to hold on to it. And the other thing which we will need in there is the stream to basically send things on. So we actually capture that as well as a reference. We can capture it as a reference, and then we have just the body of a function. This guy over here just completes with an empty argument. So we actually also get an empty argument into the function into let. And all we need to do over here is return a sender. The sender we can return to do just the same as we do over here is actually the same as this. And if everything goes well, this is all we need to do. Do I have all of the guys? Say? Okay, I get that. I actually don't hear enough of what's went wrong, but. Oh, yes. Yeah. And I need to put the. this and no matching call 4. Oh my God. This is not what I was gambling on. All right. Now, admittedly, you see me having a problem which I had hoped not to show, and that is sometimes if things are a little bit messed up, you get a lot of error output, and you go, what does it try to tell me? Actually, I think I know what it tries to tell me, and that is although maybe not. I hope it just tries to tell me that I return a value and I actually don't expect a value or something like that. All right, this happens when you deviate a little bit from what you plan to do exactly, but okay. Okay, not that then. This guy wants 3 values. Make client. Okay, I spent 2 more minutes, and if I haven't found that, I show something else first, and we may get back to that.
Oh, yes.
Well, okay, nothing over here should change, right? Well, okay. So the comment over there is, oh, I still do a core wait in my when calling send response, but I intend to do that, right? I just had a coroutine, and I just replacing the implementation by, instead of returning a coroutine, returning a sender, right? And this is what I believe I'm returning right here. Right, this should be a sender which does something, and more specifically is a let value which returns an internally a sender which is an async send. That should be fine. And I just thought, maybe it doesn't like that it returns something. Okay.
Why do just plus let value? Why not return async send directly?
So I cannot return async send directly. That is an excellent question, because that warrants some explanation, and that is the data I built over here, right? I basically built a string with data. If I were to, as somebody just suggested, basically do that, that would be bad, right? Because this does not copy the data, that maintains the data, and the data is on the stack. So that would immediately use the data which is sitting on the stack, and that is not where it lives. So we don't want to do that. This is the idea of the let value, right? We basically return a sender which basically internally holds on to the function object it has, and inside this function object we actually have references. We store the data and the stream in this case. So okay, that's a little bit awkward. This is also not quite the way I had practiced it, so I cannot look at my previous code to say this is what we do. Let's skip that for a moment, and we just go and do something else, because there are other things which may be interesting to do. Well, there are certainly other things which are interesting to do, and we can get back to that. There's almost certainly just a silly typo sitting somewhere. Let's disable that one and re-enable that one, so we basically still have it. And we could go back and find out what went wrong. Got sorry, I hear there's a CPP reference on.
Yeah, I just said if you want, you can go to the CPP reference specification of the stood exec, because
Okay. Okay, so it's the documentation is on there, but I doubt it tells me what I do wrong exactly over here. But can you give the mic to Inbal by any chance?
Can I just add, can you possibly be missing parentheses at the end of line 84? If it's lambda.
You mean these?
Yeah.
No.
Okay.
But maybe, and I just learned yesterday that maybe I'm just missing immutable or something silly like that. Oh. Oh, wow. Thanks. So the parentheses were on the right track, although not quite. So interesting. Okay, that is a little bit weird. And the arrow message, unfortunately, was not pointing in the right direction, right? I think, although I didn't read it fully. All right, let's try whether that now works. Oh, it's now. Error, no matching.
Where does it? Yeah, does it? Which? Where does it match?
Oh, this is so. This guy is the parenthesis for the let value.
Oh, okay.
This
sorry.
is the. Yeah, I don't know how to best show these things. Okay, I don't know. Let's go do something else. There are other things which I also want to show, which are a little bit in a similar direction, but different. Okay, so one thing which you may or may which you may or may not have noticed is when I run things over here, I go into the server and I load the page, which hopefully reloaded things. You see that I'm inside the client and I stay inside the client. So this can very easily get me out of resources. For one, I probably should deal with the keep alive. But more importantly, if somebody just creates a connection and stays with the connection forever, it's a very easy way to run, to force my server out of resources. So you probably don't want that. And one thing which is kind of neat is maybe is how we can create, without touching much of the things, something like a timeout. And I think this is something which may be quite interesting to see. And that's what I think would be cool is if we could just go and say over here timeout, and we just say, well, maybe we give the user 5 seconds to do something. And because the timeout will need to execute something, I give that thing a context scheduler to basically have a place to run a timeout or run a timer. And then we create a timeout, which is basically consisting of the scheduler where we want to run things. It takes a duration, and the other argument it takes is basically a sender. It's actually a coroutine task over here, but we create a sender. And what we do in here is a similar attempt as the other one. I will create essentially a sender, which is one of the senders you actually cannot easily create with coroutines alone. You can write a coroutine thingy which does something like that, but it's a little bit fiddly, and doing it with senders is actually easier. The idea is to have basically an when any, which will run as one of the things a sender, the sender we basically passed in. We can just move it because we get it as a variable. And then the other thing it should do is, well, we either complete with finishing the connection to the client, or we could go and say, well, maybe we have something like an, I call that consistent with the others with async, something like async resume after. And we just say, all right, this guy is running on the scheduler and is running for duration. So we have basically 2 items of work when any can deal with more items. Likewise, there's not just when any, there's also corresponding when all, which completes when all of these guys are done. This guy, basically the way it works is when one of the work items is done, it cancels all the others. They may have been completed already, but it definitely should finish. And that should actually give us the ability to go and say, this is where we, this is how we finish things up. Right, this guy is not called scheduler, it's called get scheduler. Oh, yes. And this error I understand, and this is kind of something which is on the one hand interesting and on the other hand maybe a little bit annoying. When we spawn something over here, the async scope goes kind of, you deal with all the problems. What it says is it actually only accepts 2 completion signatures in the spawn thing. One is a set value without any arguments, because hey, if you have arguments, you probably want to do something with that. And the other one it accepts is a set stop, which is coming out of cancellation. What it does not accept is any error. Right? So if you want to spawn anything and you have an error in there, you need to deal with that. All right, fine. Let's deal with the error. Over here, we currently don't really create any interesting errors, I think. So we can just go and say, if we get an error, upon error, we do something. So we get 1 argument. This is how the error signatures always look like. And we don't do anything. We can go and say, received an error, and we could maybe report what the error is. I will not try to report the error though, because I know what the system thinks, and that is it thinks something is throwing an exception. So the error object you get in there is basically something which is caught potentially, and it basically thinks there should be an exception pointer you need to deal with. You could obviously deal with decoding exception pointer. You basically do a try block, rethrow that thing, and print the error in the catch or something. But this is dealing with the error. Okay, that now compiles, and now we should see a little bit different behavior. We basically go run our thing, do the request, and hopefully in not too long, about now, you see that it exited the client after the timeout hit. So, and I think this is one of the really cool things. You can nicely compose these things because cancellation is directly built in right from the start. We basically get the cancellation sort of out for free, and we can easily build something like a timeout with whatever work graph we have. Okay, so, and this is to some extent also showing how you basically most likely build up senders, which they compose one sender or a new sender out of some work graph consisting of other existing senders. This is basically, there's 3 main ways how senders are created. One is you just create a coroutine. This is the easy route. One is composing these things, which is for existing work items, you just compose things in a way you want them to be. And the third one, this is the annoying one, I'm not going to show that. I did show that actually 2 years ago. This is basically when you want to create new kind of work, whether it is a new algorithm or connecting to exposing some asynchronous work like I/O thingy, or maybe you have an existing functionality, an existing library, which let's say, does a database connection and calls a callback when it completes. You could wrap that into a sender. This is probably not composed out of existing senders, but you possibly write a sender with all the internals to build that up. That's a little bit wordy, but only happens rarely in the sense of once you have one of these things, you just use it and compose it. But this is the, after coroutines, I believe basically something like that, composing a sender together, is the second most common way to create senders. Okay, so the other thing which I hope does work, I'm not entirely sure because I did spot something which is not quite ideal, is bringing up a server, responding to things is all kind of cool. Eventually, it would be nice if you could have a nice, clean shutdown and we could just go and say, let's shut down the entire system and hopefully it cleans up everything. So let's do something like that. The way I would go about that is to say, on the async scope, there's actually a function as I hinted at before, like request stop. Now we actually do some work and basically maybe we have a side channel. I will just go via the normal HTTP server. And a real HTTP server, you surely wouldn't have a channel which is open to everybody to, all right, exit your server. But you can imagine how you create a second server or a second channel in some shape or form and get that. But that's not the actual interesting bit. It's more like kind of how would we shut things down. And I think all we need to do over here is really, let's go, we check whether the method is still get, and our URL is maybe, you may have seen that already, then I have a exit sitting over there. If I get exit, I probably want to send something, like maybe I send a response and I say just shutting down. This is obviously not valid HTML, but fine. We don't really care about that bit. We can do that if we want. And then we would basically need to get over here the scope. We didn't have a scope yet. So auto ref scope. And in theory, all what would be needed is we do scope. The scope has a stop source. And then on the stop source, we do request stop. Okay, and the only missing bit at the moment is the client currently doesn't get the scope. So somewhere here is we need to pass in the scope. Okay. And now a little bit of moment of truth comes and say, let's go, I will set that up so that we can skip over that. So I will ask that guy, go here, ask that guy. It says shutting down, and unfortunately it says that. I need to wait for async scope. Oh, okay. Say? Yes, okay. So we do, what Lucian suggests is we do async wait over here, waiting for scope dot, I guess on empty or something. Is that what we need to do? Okay, let's try that exercise again. So we do a request, we do load that. It is probably closer, we need to wait something to that. But actually the error message does not really say the async scope is not empty, it says bad variant access, which is probably somewhere in some of my senders, I just internally have a little problem. I'm not gonna debug that. But in principle, this should be, and thanks for Lucian for pointing that out. I actually forgot entirely. I did that in the past, but the async, the sync wait over here to basically say, all right, we are basically done, and now we need to wait for the scope to have cleaned up, was something I was certainly missing. This should actually result in a clean shutdown, and you should see, well, we do see that the client server is exiting, the client is exiting, and so on. So that all kind of reasonably nicely works. Yes, my implementation contains a bug, and maybe there's something which is not quite right, but it's not a massive change, and that should actually yield a clean shutdown, which I would think would be actually kind of quite impressive if you ever have tried to create an async system which shuts down easily and cleans things up. That is non-trivial. It doesn't, but I promise it can. Okay, so pretty much these are the things I wanted to show. Now I can still happily go on and implement if people have some sort of requests, can you stick that in or that? So there's some time. I was actually faster than I expected. Yes. Microphone coming.
So you ask for a request. This is maybe too much, but a client of this server, is that way more easy than this?
A client of the server should be way more easy.
Yes, as I would expect. Or maybe it's out of scope. Maybe there are simpler requests as well.
Okay. So a client in principle does, roughly speaking, the same, just the other way around. But okay, fine.
Yeah, if you don't find it interesting, also fine.
No,
yes.
I'm
Yeah.
What do people think? Client interesting? Yes, no? Yes? Okay, some people are interested. Yeah, that should be fine. Okay, let's see. How do I do that? I will need to change my CMake file to include. Okay, come on. Okay, client. Okay, then I always love if I have a little bit of a framework sitting somewhere. HTTP sample to ACCU client 2024. Okay. All right, now we go entirely out into the wild, but that's fine. All right. So the client right from the get-go can be a little bit simpler because all we need to do in the client is we need to kick it off and run it. Okay, fine. So to actually do something, we need to have an I/O context as before. I need a place to kick it off. Although I have only one work item, really that would be the client running, I will just stick it into an async scope. So async scope, and the client is basically going to be scope.spawn, make client. We gonna need some things from the scope to basically run something. And then we do the same things as in the other one, context.run and sync wait scope.onEmpty. And then we just need to create a task. Exec task void make client context. We need to pass that as reference. And let's go. We probably also want to give that thing a URL in some shape or form. So I'm not going to really enter the competition to implement something like curl, but like curl, right? So we have arguments, that, and let's say we go over here, we request in make client, if that is 1, 2, we do that, and if we just run it, we request that. AV1, yes. Otherwise, I would need to rename the program every time. That would be awful. Say? Make, oh yeah. Oh, and but I closed that. All right. Line 17, I'm missing a colon. But okay, I have done that at least twice so far. Who else is missing colons on a regular basis? Okay, thanks. And the error messages are sometimes weird, right? Because sometimes it even compiles and you just hit a label and you call something entirely unexpected. It's kind of, oh my God. Okay, so what do we do in here? We basically, first we need to send something. And let's just go and be reasonably sloppy. SDNet, we do async send on, before we do that, we need the client. Not nearly as simple. So the first thing is we need to actually get a stream with a client. So do that, let's do that. I think I would need to look that up possibly. I think I do that with async. How am I doing that? Git grep async connect. Okay, fine. Okay, I actually don't do it like that. I have an SCNet IP TCP. Okay, I don't have, this is one of the typical problems I haven't written documentation yet. Okay, I want one of these, and this should be just a stream socket. TCP stream socket client. Okay, I will use what I'm using over here. Stream socket. Oh, okay. Yes, that makes sense. This is SCDNet IP TCP endpoint of. We basically did SCDNet IP address before. Probably that one should work. Stream socket, less VI stream socket. Okay, I do create that with, yes. I like to forget that. I always think, all right, it's like in BSD, where you basically can create a socket just without any context. However, it turns out you really want to have a context. The reason you want to have a context is on some systems, like if you use IOCP, the Windows IO completion ports, you cannot create a socket outside any context. You need to bind it directly to a context, and you need to execute it on that context. On POSIX systems, that often is not quite the case, but once you use something like IOU ring, you actually can benefit from knowing that it is running on a specific IOU ring instance, so you want a context. But this is what I like to forget when creating these things. And I clearly do more errors. No function, non-void function does return a value. That is in 6.9. Okay. So this is easily fixed. We just need to do a core wait at some point. Anyway, so core wait async connect. That should do that guy. Oh, and this needs to know where to connect. Okay, all right. Now we are way more in game. Now we need to send something, client, and we send a buffer of the request. And the request we build is just do a string request of, what request do we send, right? so now we need to speak HTTP. HTTP, we know how we started. We basically started with get. We want to get the URL. We claim that our version is 1.1. And we need to have a new line after that. And let's have an entirely empty header because we know something about the server. We know that is sufficient. So we do that. And we just send that. That should be enough for sending the guy. Okay, excellent. And now the other direction is, okay, let's do a vector of char with, well, let's do bigger, well, whatever, that should be enough. And we do, followed by that, a core wait of svnet async receive of client svnet buffer of b, and we should figure out how much did we receive, and then we do cout received equals, let's do a little bit of a delimiter over here. What did we receive? We received a string view of b.data, and I think n does the trick. Oh, okay. I have an excess colon to spare for. Maybe the compiler could just go and say, yeah, balance them out, or here's some. Okay, so now we should have a client. Okay, this guy will run the server. Where am I? Over here. Okay, so build a client, and we do that, and it actually got that thing through. All right, cool. So anybody having any questions? And while we have question time, I can actually go and get back to this guy. Before questions, the slide should be available. This is the links, the implementation for stood execution for the sender-receiver stuff. My own sender-receiver, not quite up to scratch and certainly not complete implementation in my GitHub. The proposal for the async scope which was used. And with that, I'm happy to answer questions, and you may be interested in how to apply at Bloomberg. Okay, anybody, any questions?